at the night time. As we gaze at the open sky, we see not only twinkling stars, but also celestial bodies floating in space, such as comets, planets, and massive galaxies. If somehow we could reach one of these planets in our solar system and look back towards Earth, our planet would appear as a sparkling star in the sky. Similarly, if we could travel thousands of light years away and observe our sun from a distant planet, it would appear as an ordinary twinkling star among countless others. The sun is the heaviest and largest object in our solar system, often referred to as the chief of our solar system. The sun controls all, illuminates planets, moons, and vast celestial bodies with its gravitational pulse and self-generated light. In this infinite universe, how did our solar system come into existence, and how did the sun, planets, and moons form within it? Scientists attempt to answer these questions based on theories and experiments conducted on examples taken from ancient celestial bodies that have been orbiting the cosmos for millions of years. According to the nebular hypothesis, our solar system's formation occurred due to the collapse of molecular cloud made of dust and gases. This concept was proposed in the 18th century by astronomers Emanuel Swedenborg, Immanuel Kant, and Pierre Simon Laplace. Initially, it faced opposition as it struggled to comprehend the angular motion of planets compared to the Sun. However, the discovery of new stars in the 1880s supported the nebular hypothesis, and it was eventually accepted. Later, with the Hubble Space Telescope, image of protoplanetary disks in the Orion Nebula were captured, providing practical confirmation of the nebular hypothesis. Nebulas are clouds formed of dust and gases after hundreds of light years, and within them, stars are born. Newborn stars are surrounded by cooled disks made of dust and gases, known as protoplanetary disks. It is from these disks that planets, moons, and celestial bodies emerge. We will talking about ahead in this video. We will delve into the detail of how these protoplanetary disks gives rise to planets, moon, and celestial bodies. Coming back to the topic, fragment of the primordial cloud that led to the formation of our solar system spread over approximately 65 light years during its development, with each fragment have a radius of about 3.25 light years. The collapse of these clouds eventually formed a dense core-like structure. One of these fragments gave rise to our solar system, referred to as the pre-solar nebula. This term is used to describe the early stage of the solar system, where no planets or moons, including the Sun, had formed at that time. The pre-solar nebula was composed of approximately 98% hydrogen and helium, making up the bulk of its mass. This structure was quite similar to today's Sun. The remaining 2% of the mass contained heavier elements. Some scientists believe that the pre-solar nebula's formation occurred through the supernova explosion in the star named Kotelleq, which might have been about 30 times more massive than our Sun. Following the explosion, the gaseous clouds in the nebula were compressed under immense pressure, giving birth of the Sun and hundreds of stars. As per the conservation of angular momentum, when the material inside the nebula started condensing, the nebula began to collapse rapidly, causing collision between particles. The kinetic energy of these particles converted into the thermal energy in the form of heat. Most of the mass started accumulating at the center, creating a highly heated region compared to the surrounding disk. This process continued for about 1 lakh years, during which gravitational force, gases, pressure, and magnetic field caused the nebula to contract. It formed the spinning of protoplanetary disks with a diameter of around 200 astronomical units. In this disk, the center, an extremely hot object formed, known as a protostar, where nuclear fusion reaction had not yet begun. Our AU is a unit of measurement using astronomy. presenting the average distance between the Sun and Earth approximately 150 million kilometers or 15 million miles. NASA scientists observed a protostar forming in the L1527 nebula during the James Webb Space Telescope, discovering that the star nurturing nebula only becomes 50% or fewer protostars actually transformed into the stars. This implies that if there are 10 protostars in the nebula, only 5 or fewer may eventually become stars. Jupiter, located in a solar system formed by combining elements similar to those found in the Sun. Scientists speculate that the Jupiter might have been a protostar during the early stage, which failed to become a star. So Jupiter has much less mass than the Sun and is a fact the oldest planet in our solar system. Interestingly, Jupiter had successfully become a star. We might have to witness two suns in our solar system today, leading an entirely different circumstance on Earth. Over approximately 50 million years, the protostar's temperature and pressure increased into the point where hydrogen began nuclear fusion. Helium and energy were generated and it completely transformed into a sun. We now know that star as the sun. Studies of rare elements in the Kuiper belt of our solar system reveal that not only the sun but also around 1,000 other stars were formed. As time passed, they gradually moved away from each other. Formation of planets. It is believed that after the formation of our sun in the nebula, the remnant of gas and dust disk gave rise of various planets. The leading theory regarding the formation of planets at present in the accretion theory. According to this method, due to the influence of dust and gas surrounding the sun, tiny particles started accumulating directly around the sun. In the early stage, these particles with a diameter of 200 astronomical units collided and organized themselves into larger bodies with a diameter about 10 km over the next few million years. Within the solar system, the region up to about 4 AU is too hot for a condensation of water and methane. As a result, condensation of metals like nickel, aluminum, and rocky silicates lead to the formation of rocky objects. After several 100,000 years, the accumulation of matter caused the collision between the massive bodies gave rise to the planets, Moon, and larger spherical body, the planet Mercury, Venus, Earth, and the Mars. Along with Jupiter, Saturn, Uranus, and Neptune were formed. It is believed that the formation of Moon around Uranus and Neptune occurred after the formation of Jupiter and Saturn, when the Kuiper belt located quite close to the Sun during the early stage of solar system slowly moved away with the time. About 3 to 10 million years later, solar wind split gas and dust from the solar system into interstellar space. Only planets, moons, and larger spherical bodies remain into the solar system, and the formation of new celestial body caused. Moons. Several moons orbit around Jupiter and Saturn, such as Europa, Ganymede, Titan, and others. According to the scientists, these moons primarily form into three ways. Number 1. Similar to the process of planet formation around the Sun, moon formed by the direct accumulation of dust and gases around the gas giant. Jupiter and Saturn. These moons are larger and orbit around Jupiter and Saturn. Number 2. Moons formed due to the gravitational influence of massive planets, mostly in irregular orbit. Most of these moons revolve in the opposite direction of their primary rotation. The larger moons, Triton of Neptune, was captured from the Kuiper belt. Number 3. The third reason for moons formation involved controlling large bodies passing through the outer region of the planets. This mechanism was used to control small moons of Mars, such as Deimos and Phobos moons. According to the astronomers, Earth's moon, also known as Theia, was formed after collision with the Mars-sized planet named Theia. Theia orbit between Earth and Mars, slowly being pulled toward Earth due to Earth's gravitational force. Eventually, Theia collided with Earth, resulting the theories of this form of rise around the Earth over millions of years. This drive organized itself into the larger body, giving rise to the moon as known as today only natural satellite of Earth, the asteroid belt. The asteroid belt is situated between 2 to 4 astronomical units from the Sun in the outer region of our solar system. This belt contains numerous asteroids and comets, and scientists estimate that the celestial body could come together to form 3 planets similar to the Earth. It is speculated that these millions of years after the Sun formation, this region might have been a place where planets were forming. Due to the gravitational pulls of Jupiter and Saturn, disturbance in the planets occurred to their velocities increase significantly. This leads to collision between them, transforming into the smaller celestial bodies. This asteroid belt exists in the extremely cold region orbiting to the Sun, where the sunlight is most negligible. Water on this asteroid remain in the form of ice. Scientists believe that comets which have similar composition might have allowed water of the Earth comet store water in their reservoirs. And according to the hypothesis of fresh Permian, life on the Earth could have to originated from these comets. However, this idea was not being widely accepted. So in this video, that's all for now. Stay tuned to more knowledge and mysterious in the next video. Until then, goodbye and Jai Hind.